I picked up one of these Banner IC70s, and I gotta tell you, this is a really cool device for a couple applications that have come up recently in our training class. So what this is an IO-Link in-cabinet discrete input and output module. So you can have 16 discrete inputs or outputs. They're all configurable. And so what if we just run out of IO? It's a great way to add some IO if you have an extra IO-Link port. But also, we've had several people recently that really wanted to pick some devices up and kind of throw them up on Modbus TCP or something, maybe to go into ignition. So they really need a PLC there. And so with the FIN20 and many of our IO-Link modules, we can make them into Modbus TCP servers. And so what we're going to do today is we're going to go ahead and add this into, well, we're just going to connect it to the FIN20. Let's just see what we can learn with it on an IO-Link module. So I'm going to go to 192.168.185. That is this IO-Link module. And I'm going to go ahead and log in. And then really without even doing anything, I probably can go down here to channel, well, everything's going to be at zeros right now. So I guess that doesn't do us a lot of excitement. So let's go ahead and go to the IO-Link or the IODD configurator tab. And if I go to port 4, it does know we have an IC70 there. And I already peeked into this, so it has IODD installed. But just so we can see how we could, I'm going to unlink the IODD. And then we could either hit the web search button or we can just hit the load IODD file. And I've downloaded this off of Banner's website, and it's usually going to be an XML file. You'll also have usually some images. It looks like they've got some instructions to help us out in this one too. I'm just going to hit open on that, and that would make it where we can get all the process data and the diagnostics and the real cool stuff. So the first thing I'm going to do is I'm going to go to the process data tab. And here are our inputs and outputs. Now we need to go look and see how they're configured first. And we're going to do that on the parameters up here. And then we can go down through here. And mainly right in here, we have individual channel configuration for each one of them. So they can be a PNP input or they can be a PNP output. And by default, they're all configured for outputs. And, you know, honestly, this is probably going to make it where we can at least see a little bit of stuff in Studio 5000. So I'm going to leave it like that. But for now, we're just going to go back to the process data. And I'm just going to flip on the switch on output 1. And when I do, that flips on output 1. So that easily we can read and write to this device. So now what we want to do is we'll probably look at two ways. First of all, yes, I want to look at it in Studio 5000. But also, since it's on Modbus also, as long as you know the address blocks, then we can go ahead and read them. So let's figure out how to install this in the Studio 5000. And this is a file that I just already have installed on this. And we have worked with this file many times, but the main thing is it has the IO-Link module installed. And so since it has the IO-Link module installed named IO-Link, if I open up my controller tags, and I just type IO-Link, then there's my inputs and my outputs for this. Now, if we open this up, then yeah, we need to figure out which one of these is the one we actually need. And so to do that on the Turk module, we're going to go to the documentation, and we're going to look at the Ethernet IP memory map first. And so the IO-Link channel 3, which is what I have it plugged into, it starts at word offset 50. And then the outputs, coincidentally, they also start at word 50. Now, don't always assume that. Sometimes they don't line up like that. Now, let's say we didn't even want to put it into the PLC. We just want Modbus TCP. Well, that means I can go over here and its data will start at 49 as far as Modbus TCP inputs. And then our Modbus TCP outputs for channel 3, they're going to start at 8131 right here. So just by knowing these numbers, we could read this into ignition and we'd be done from here, which is a really cool feature for a lot of us out there just trying to log some data. All right, we're going to add this on to Studio 5000. And for that, we're going to need an add-on instruction that you can download right off of Banner's website. So if I go here and we go down a little bit, we have downloads. And then there's the IODD file. And here is the add-on instruction for it. I've already gone ahead and downloaded those. So now I'm going to right-click add-on instructions, and we're going to import an add-on instruction. And there it is, the Banner IC70. We're going to open it up. And okay. And then also in that file, there are some instructions that we need to look at and just clarify a couple items. So I'm going to go into it. And we're going to open up that PDF file. And so, yeah, we just imported this add-on instruction. And the next thing we have to do is configure it. So we're going to go ahead and bring a new rung down. And I'm just going to do this right at the top of my main routine of this one. You could do it in a main program too. And then I'm going to go to that add-on tab, which is just to the right of our favorites tab on the instructions. And we're going to drag down that Banner IC70. And I'm going to call this my IC70 status. And I'm going to call this my IC70 process data. And then I'm going to right click, new. And notice it makes a user-defined data type, and it'll be fine just like it is. We're going to hit create. And I'm going to do the same thing with our process data. And then the byte swap's always a little bit tricky, but it's awesome that they have this built into the Banner add-on instruction. And I'm going to start with a 0, and I'll show you what it looks like if you have that one wrong. Okay, so now the next thing it's telling us to do is we need some CPS copy instructions. So this is a time to use the CPS instruction also. And we have some videos talking about the CPS versus COP instruction, but our data could change midstream of this. And when that can happen, we want to use the CPS. And so notice we have one on the left side of that add-on instruction, one on the right side of the add-on instruction. So I'm going to go over here to my file miscellaneous category. And I'll bring down a CPS on the left and a CPS on the right. And then it's telling us to go to IO-Link data 184, but we just found over here that we need to be at 50. So we're going to go to 50 on ours. So mine is called IO-Link, and then it'll be :I data, and then 50. And then our destination, it's saying is going to be our process data DTI 0. And it is a length of 2. Now, pay attention. I'm not going to do exactly what it says on the second one here. But so on this one, we're going to go grab our IP70 process data DTI 0, and we're going to make the length 2. Now, on the output side, first of all, notice they swap. We're going to go find the IC70 process data DTO 0. So I'll put IC process data, and we want the DTO, and then we'll get 0. And our destination is going to be IO-Link :O, and then data, and we want to get 50. All right, now there's a catch to our length, and we need to make sure we understand this. Probably causes us more grief than it should. Is your length is based on your destination. So this is an integer, which is 16 bits. The DTO is a small integer. Oops, can't move over that. But it's a small integer there, which is 8 bits. So if we double click here and we look, we have 2 small integers. So 8 bits plus 8 bits is 16 bits. Down here, this is an integer, which is 16 bits, which means we only need a length of 1 to make that match up. We have a lot of videos going through this because this probably causes us way too much grief. But we'll go ahead and finalize that. And now we should be able to right click our process data and we're going to monitor it and we'll open it up. And now, instead of going to the DTI and DTO, we're actually going to go to the PDO because we're configured for outputs. And what this has done is instead of us having bit 0 be output 1, now we have C1 out. And if I put a 1 in here, now while we're at it, let's talk about that swap byte and what it would look like here, because I think this, honestly, this probably is a really good example because usually we're just throwing terms in there trying to make the stuff make sense. But here's probably a clean module to talk about that swap byte on. Is I'm going to start running it and I'm going to 1 in that swap byte. That's going to enable that. And as soon as that goes in, that makes it it's bit 8, but it's output 9. So that means that these 8 bits are swapped with these 8 bits. And so if you put it in and output 9 comes on when you tell output 0 to come on or output 1 to come on, the first number is 0. I struggle with that if it is. Then that's where we need that swap bit. So in that case, you would just go in here. If you have a 0 in it, put a 1. If you have a 1 in it, put a 0. And that'll get your data straightened up. It's a really cool module, Banner. I mean, I'm not sure where I'm going to use one of these at the training center, but I probably should find a place for it because there's a lot of times that, we just need to collect some data and we just want to throw it up, into the cloud or into an Ignition server. You don't really need to throw it into a PLC. So, nice lean. And 16 configurable inputs or outputs.